All right, so in section 9.4, you're using the formulas to find the area of triangles. So you have three different ones. If you know the height of a triangle, it's simply going to be 1/2 times base times the height. That one is just review from geometry or algebra 1 or algebra 2. In other cases, if you have oblique triangles, when it's not a right triangle, if you have side angle side that's given, you can use 1/2 AB sine C. So it's a little bit of a twist in there. You still have the 1/2 times 2 of the sides, but you're also multiplying by the sine of the angle that's given. If you don't have any angles given, if you have side, 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 then what you're going to do is compute a value known as S, which is 1/2 times the sum of the three sides, and then you'll be plugging that into this formula here. So 9.4, as you can see, is very formula based. If you stick to the formulas, it'll make your life very easy. So first we have, it says find the area of the triangles. So we're going to use the side angle side for our area. So we're going to do K equals 1/2 times 2 times 7 times sine of 40. And then this will give us our area. And K equals 4.4995, so 4.5. So now in this case we have side, side, side that's given to us. So we're going to use both parts of this formula. First we need to figure out what S is. S is going to be equal to 1/2 the sum of the sides. So 3 plus 5 plus 7, which is 15. So 1/2 of 15 is 7.5. And then we plug that into our formula here. So K equals the square root of S, so 7.5 times 7.5 minus each one of our three sides now. So minus 7 times 7.5 minus 3 times 7.5 minus 5. So K is approximately 6.495, so 6.5. Now it says find the area of the shaded region, and this is just the formula for the area of the sector, reminding you that the area of the sector is 1/2 r squared theta. And remember that theta has to be in radians in order to use the formula. So let's go ahead and just convert 75 degrees to radians right away. So let's put our calculator in radians mode, and we'll do 75 degrees. So that is 1.309 radians. So for our theta, that is 1.309 radians. So now, first we need to find the area of the sector, and then we need to subtract from that the area of the triangle to get our shaded region. So we're going to do, so the area of the shaded part is going to be the area of the sector minus the area of that triangle that's there. So to find the area of our sector, again going back to the formula, that would be 1/2. R is 8 squared and theta is 1.309. So 1/2 times R squared times theta. That gives us 41.89. And then we do the area of the triangle, which is going to be, let's see, we have side angle side again, because if this is 8, then this is still the radius of the triangle, it's just going vertical. So this is also 8. So we're going to do 1/2 times 8 times 8, which are our two sides, times sine 75. So calculate that. This will be 1/2 times 8 squared again times sine 75. So we get, whoops, and my calculator is still in radians as you can see. So let's change it back to degrees and then fix that. So we get an area that is about 30.91. And now we simply need to subtract these two areas to get this remaining shaded region here. So we'll do 41.89 minus 30.91, and we get 10.98. So the area of our shaded region is 10.98. Our last one, it says use the formula to find the area with the dimensions. So this time they give us everything we need to know. All we need to do from here is plug everything into the formula. So you see that what's given here, we don't see an angle. We only have angles A and C, but remember you just subtract those from 180 to get the missing angle. So if A is 120, C is 10, then B is going to be 50 degrees, and that will add them up to 180. So then we go ahead and plug everything in. So K equals C squared, so 9 squared sine 120 sine 50 all over 2 sine 10. And then we calculate that, and we get K is approximately 154.73. Just a little bit of caution when you're plugging these problems in. If you're plugging everything into your calculator at one time, just be mindful of putting a parentheses around the entire numerator, as well as putting a pair of parentheses around the entire denominator.